what I'm going to go ahead and do is I'm going to go back to the load hanger here. I'm going to go ahead and remove this. And we're going to run it again. It's going to crank in the background, and at that point, while that's happening, loading up all of that data, we are going to go ahead and take a look at PyTorch Lightning and go ahead and get a Lightning version of the training loop set up. Let's go ahead and kick that off. Oh no, we're still running train hanger. So we want to come back here, do this, and now we're loading. Cool. All right. New Python file. We're going to go ahead and start this one from scratch. We're just going to call this lit.py. Okay, so everyone at this point should go ahead and pop over to the PyTorch Lightning documentation. Let's take a look at, okay, if you scroll down, so we're just going to go ahead and grab the example that they've got. Environment map size limit reached. Okay, so this is where we need to tweak our, go back here to load hanger for a second. As you recall, we set some sizes smaller than they exist normally. Move that around. So we're going to go ahead and try that again with a gig. Oops. This got named poorly. All right. Grab some more data from their example. Okay. So we're going to be stealing a bunch of stuff out of this training hanger stuff. So I am not going to worry so much about supporting a bunch of the command line arguments and that sort of stuff. This isn't about making an exact one-to-one replica. It's actually more about showing you, it's like, okay, here's all the stuff that we can do in Lightning relatively quickly, and here's all the stuff that we need to leave behind. So we're just going to take the model class, we're going to skip all the fine-tune stuff, and we don't need the CUDA things. So coming back over here, so this we are going to take a look here, and we're just going to call Luna model. So yeah, sure. Okay. And we're going to get rid of that. Okay. So we actually don't need this. The self.forward model, like self.forward and PyTorch Lightning, I think is a little bit of a trap. We shouldn't use it because you shouldn't be calling .forward directly. So training step. This is going to look very similar to what we just saw here in the original. So compute batch loss. We start off with a batch tuple, and we return with a loss, and we end up with a loss. So we're going to go ahead and just grab all of this. Oops. Interestingly, we even still have self.model right here. So we're going to go ahead here. We're going to do self. Turn that into a self.augment. Need to get a couple more imports. where did batch size passed in? Yeah. So here we'll just say rename these just a little bit. Okay, so don't need that. We'll need to get the appropriate NN imports. We'll grab those from here. These imports are going to be a mess, and that's okay. Skip the logging stuff. One of the things we're going to also skip a little bit of some of the metrics. We are going to have them. They just look different in Lightning. Okay. So I'm gonna have to go look up something about how you can return multiple values from your training step. But this remains the same. So we're going to go ahead. For now, we're just going to worry about the loss. We'll come back to the other stuff in a bit. It looks like our data should be finished around 6:15, so another 15 minutes or so. Then we should be able to go ahead, pop back to the original training loop, see that go a little bit better, and then we'll come back to the Lightning stuff as well. All right, so the validation step is going to look very similar, and in fact, it's going to look exactly the same. Copy these. How did that get all crazy? All right, so we've got our validation step. We're going to do the exact same set of things with the validation step, except we're not going to augment. And likewise, our metrics will be a little bit different. Let's see. So let's see. We've got configure optimizers here. So let's go ahead and pop over here. We did something similar. So we'll go ahead and set fine tune to false. So our data set is going to look a little bit different than what they've got. We will come back here. So they handle the data loader stuff for us. Oops, didn't need that. So, oh no, they do want the data loaders. My mistake. So one of the things that Lightning has is they have this data spec that I'll need to take a look at here in just a moment. Oops. Okay, so coming up here, we'll need to make sure we get this stuff imported. Okay. Get some. Cool. Just gonna get the. So we get our training data loader and our validation data loader, and then we can go like so. Okay. Cache stuffing seems to have slowed down. That's a bad sign. That's not super surprising. I would like to check on disk space. How are we doing? Still plenty of room. I'm not sure why that's slowed down. Let's see, we added about 10 minutes. Thinking we're probably going to want to kill that and restart it, but with only 112 positive samples. That's one of the problems with this data set, is that there's so few positive samples. It's very hard to work with. What we can do is we can set it up to sort by, to get those 112 first out of the, actually no, it's going to be about all of them. I'm not sure. We'll get that figured out here in a second. Get rid of that. Okay, and honestly, I believe that this is enough to start running training. Like, the amount of stuff that you have to do in order to get things running under Lightning is really, really small. Let's come back over here and we'll do something like this. If I think we're going to have to go ahead and kill this. We'll let it commit for a couple, and then we'll kill it again. We'll have workable data, and we'll go from there. So stop that. Run it again. Okay, so one of the things that we talked about is adding a training or not flag to this. One of the things that we could do is, if we come back to data sets here, we can get our candidate info list, or actually we get our candidate info dict. All right, so come in here and we're going to say get candidate info dict. So we start off what we're going to say is, all right, I want to go ahead and I want to create my training and my validation sets. We want to split by the series IDs. So we'll get a series list, which will be the keys of the info dict. Okay, so train list will be if we come in here, we can see, I want to make sure we're using the same logic. Grab this logic here. So, okay, so what we're going to say is the validation list is the series list. We'll go ahead and set the validation stride equal to 10, right? The train list is going to be a copy of and then we're going to go ahead and delete out all of those things. All right. So coming back here, we will say like what do we call that? We'll just call it isval. Let's see. Think that the bools get supported in the right way as they get passed into Torch, but I'm not 100% certain, so we'll have to see how that falls out. We would say, okay, here is is it a member of the validation set or not? And then down here, just like with index, we would have prototype.isval, and now we've got a flag running through all of it that says whether or not it's validation or not. Now, probably what we would want to do is we would also want to change label to be from label to is candidate, is nodule, is malignant, because that way we have our data set with our two different labels that we'd be storing. Yeah, we'd be able to go from there. Oh, let's see. This dot close is going to be problematic. We're not going to just be able to stop this. Let's do. Okay, so we're going to have to stop this and run this again. Anyway, anything else we want to add? I think we're going to go ahead and skip that for now, just in the interest of getting this done. So we'll go ahead and stop that, run it one more time, and see if that does the trick for us. Okay. Oh, actually that's not going to work. We need to actually then here do and we need to make sure that we actually get an isval call. Let's try that. All right, coming back to here, now what we can do is, so we decided we don't need those. What we're going to want to do is we're going to make Torch dataset, and we're going to say keys equal train keys. So train keys is going to have to be something that we pull out. And likewise down here, we're going to say val keys helps if I remember how to program. All right. Okay, that's stopped. Let's go ahead and stop this and then change this to train hanger and see if it works. Actually, we'll go ahead and leave those for now. We'll come back to this while this first training run is running. That's what I was afraid of. I think it kills it a little too definitively. All right, coming back here. Well, actually, we'll just do this. We will break. I'm not sure how many samples we're going to need in order to get a positive sample, though. We've got like 50,000 samples and only 100. Oops, creating the wrong one. Oh, whoops. Maybe that's the problem. That should get us a couple positive samples. Okay. Let's run training. Why is that not? We're only getting one sample. Oh. So let's do this. Equals, let's call it 5,000. There we go. Let's try this one more time. Let that run for a minute. Let's see. Coming back to here. Let me go ahead and poke at the, let's see. All right, so I think what we're going to want to do here is we're going to say for key in checkout.columns is val value equals well, we'll do this. We'll do is val call equals and then so value at that point should be an numpy array of size 0. So we say if value 0, then val keys dot append key. And then coming up here for train keys, we say so we're gonna leave that out for the time being, but let's go ahead and try running it. Transactional support has a child or is invalid. Oh, we increased the size. Cool. We're training. Let's go ahead and get rid of some of those debugging logs that we've got in our training loop. Validation. Yeah, right here. Get rid of that. And we can get rid of that. Okay, so kill that. Try running that again. So our batches are size 24. We've got 209 of them. That seem about right? Let's see. Let's come down to, yeah, 2 times 25. It seems 50 times 100. So yeah, that seems about right. Yeah, we've got 5 samples here, so we've got something. Let's go ahead and go back and put in the keys, the validation keys and the training keys. So you'll see here that our training sets and our validation sets are the same size, which is not accurate. And it's all 5,000, which is also not what we want. So let's go ahead and run that again, now that we've got our keys in there. And you'll see now we've got 180 training batches and 29 validation batches. 29 validation batches seems like... Oh, that's right. That's right. Because we're not... yeah, so it's yeah, about 10%. A little bit higher. Yeah, we're still getting division by 0 because we're not doing a very good job of training, but that's not shocking given... oh, we're also not writing... Are we writing the metrics? No, we're writing the metrics here. Okay, but that means now we can pop over here to this one. Let's go ahead and edit in another configuration. And now we can run this one. Oh, yeah, because we import a bunch of stuff we don't actually need. Torch Vision requires pill, which we don't have. That seems to be the problem here. Ah, right. We also need to change this. And to be clear, the problem, this hanger constants thing is only an issue because I don't have a whole lot of free space on my desktop. I thought uninstalling Witcher 3 was going to be good enough. It was not. Oh, batch size. We will just hardcode that to 24 and this to 0. Don't need that. And this will be true. Oops. All right, and there's one more thing that the Lightning stuff suggests is setting GPUs like this. And we're training on Lightning now. Lightning is one of those, it's one of those frameworks that allows you to do quite a bit, but it's all kind of opt-in. As you can see here, it's very, very simple. We set up our model, we set up a training step, we set up a validation step, and we're done. Configure optimizers, we're done. That's everything that we need to do in order to train something. And you can see it's doing, I believe, yeah, validation now. And so you can set it up so that it can log information to TensorBoard and all of that kind of stuff. It's really pretty powerful. I've looked at it some myself. I like how it's structured. I like how it doesn't force a whole lot of decisions on you that it doesn't need to. And I found the code base to be pretty cool to look through. So I'm sorry we didn't have a whole lot of time to get into what Lightning can do more. I hope you enjoyed this. I had a good time. Sorry if it was a little unpolished, but I think it was an authentic experience for using both of these libraries.